In his paper titled, "What is so negative about negative exponents?" Jeffrey Dietz does an analysis on student and author perceptions of negative exponents. If you're waiting for the movie, then earmuffs, because I'm about to spoil the ending. He found that over the past 200 years, people at the pre-college level, including teachers and authors, are increasingly trying to avoid using negative exponents. In fact, as Dietz mentions, and I subsequently confirmed, the Common Core State Standards mention negative exponents once, and that's in the 8th grade content. This is a terrible shame because all fields within STEM require the use of negative exponents. It's as if the writers of the Common Core State Standards are purposefully sabotaging the future of our youth by not teaching them the skills to become scientists. Upon finding out about this atrocity, I immediately visited the local high school down the street to interact with their math students and to see if they knew how to work with negative exponents. I challenged a group of 10 students to simplify the following problem. Needless to say, they flipped out.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes.
Hello, my name is Roy Simpson, professor of mathematics at Columbus River College in Sacramento, California. And in this review video, I am going to cover how to work with expressions involving negative exponents. So let's go ahead and get started. In defining a negative exponent, we just have to jump back to our laws of exponents and recall from elementary or pre-algebra the following. A base raised to a negative exponent is just 1 over that base to that exponent's positive value or its absolute value. So the way I'm saying that really sounds kind of confusing, but if I said the base raised to the negative second power, that really just means 1 over that base raised to the absolute value of that negative 2 or the positive 2 power. It also works the other way around. So if you had, for example, let's say a 5 over some base to the negative third power, you get to exchange that position, not the 5, but what the exponent is touching. So that exponent is attached to the b there. And so what I'm going to do is go ahead and move that base to the numerator. In doing so, I will make that exponent positive now. And this is all still over 1, and we would really not write that way. We'd write 5 times b to the third power. A lot of manipulations that can happen in here, but that's pretty much the main kind of definition of a negative exponent, that it swaps its position between numerator and denominator, and you can rip off the negative. By the way, it also works in a different order. So some people specifically like to start, if they have like a base to a second power, they might want to write that as 1 over that base to the negative second power. You are completely allowed to do that. Why you'd want to in this case, I don't know, but you are allowed to do that, exchanging positions and throwing the opposite of its sign in the exponent. We see negative exponents actually everywhere throughout the sciences, but you start seeing them really in arithmetic. And as a specific example, you actually see them when you use scientific notation. That is scientific notation, and that negative exponent there means something, right? So it just means that that number's getting smaller. So that is one place you would see them in arithmetic for small spaces, usually in the sciences. In reality, you see them quite often in algebra, so let's go ahead and throw down a few examples here. That very first example actually appears in one of our other videos. I think the video on compound fractions. And then the second example is brand new to us. That one illustrates some very interesting things about exponents themselves. These last two examples are really kind of good, advanced, robust examples. You can see there is a negative exponent on that third, I guess you would call that third expression there. And then there are negative exponents all over the place in the fourth expression. And we'll talk about those in a little bit, but those are very common. You'll see those in a pre-calculus course or in a calculus course. Finally, let's talk a little bit just about trigonometry. You actually don't see negative exponents that much in trigonometry as a in reference to just trigonometric functions, mainly because there is a bit of a confusion with trigonometry and negative exponents in the notation itself. So you don't really see them with trig functions that often, and when you do, you try not to write them with negative exponents if you can. However, you do see them all over the place, negative exponents that is, in calculus. And I should say in science, right? So calculus and the sciences, in fact, calculus is kind of the gateway to the sciences. So you do see negative exponents in those courses. Of course, there's no reason for me to write any of those examples here because this is review as you're entering into your first course at college level mathematics. When we work with negative exponents, you want to be clear about what that negative exponent is actually doing, what it's attached to. So I'm going to spend just a brief moment talking about that. So in this, as a warning, you need to know what the exponent is affecting. So what I mean by that is, let me give you actually just two examples, like a 3x to the x times y to the negative first versus a quantity of 3xy to the negative first. That negative first exponent in the first case is only affecting the y. The negative first exponent in the second case is affecting everything in that container, which we call a group, because parentheses are grouping symbols. So in that second case, the entire group would flip over, right? It'd be 1 over then that 3xy. The entire group dropped downstairs. Whereas in the first example, the 3x stays in the numerator. The y is the part that drops to the denominator. Now the second bit is more of a piece of advice. You should understand that each situation is slightly different. In fact, sometimes it can be or look to be incredibly different. And so each situation might require different approaches. Otherwise, there really is no hard and fast tactic to tackling negative exponents other than following the order of operations. I think that's a great idea, but sometimes going outside of the order of operations or maybe alternatively approaching or delaying parts of the order of operation can be advantageous. So it might be best just to dive into some examples to see how these are done or to remind you of how these are done. Here we have an example that I would definitely say the order of operations is going to be your best friend on this. So step inside that grouping symbol and tackle that first. So I'm just going to put an equal sign here because that expression is going to be equal to something raised to the negative second power. Now looking at the interior of that grouping symbol, you have x times y to the negative first. Remember that exponent there is actually only attached to the y, so we get to drop that y downstairs. And then same thing on the next term there. We have x and negative first times y. Again, the only one with a negative exponent is x, so I'm going to drop that to its opposite position, basically take its reciprocal, so that you have y over x. And so when you find the LCD and you group these fractions together, you'll get. And now finally, I'm done cleaning up that interior. We know that the sum of squares does not factor or anything like that. So we're pretty much done in this case, except we still have a negative exponent. And that negative exponent right there, we're going to go ahead and run. And the laws of exponents tell me that if I have a negative exponent on an expression, you take its reciprocal. So I will say this is equal to a group that's still being squared. But now the roles have been switched. What was in the denominator is now in the numerator, and what was in the numerator is now in the denominator. At this point, you could do a little bit more in the way of simplification because that square, according to the laws of exponents, will attach to both the numerator and the denominator. If you need a review on that, there'll be a review video on how to square a binomial. I do want to say here that when I tell you at the very beginning of this problem to simplify, I'm really saying write this without negative exponents. It's a very bad thing that modern textbooks have you write things without negative exponents because, to be honest with you, in science, you'd like to leave everything with negative exponents. However, you have to get used to working with negative exponents, so this is just a review video to remind you of how to do that. So this one is done. This was in our introduction to this section or to this review video. And this is a very interesting example. I'm going to use several laws of exponents here. So those 2's have the same base. So again, I'm jumping inside this grouping symbol here, and I'm just going to simplify this stuff as much as possible. They have the same base, so using laws of exponents, I could just call that, and then that's all being still raised to the x plus 2 to the negative first power. And I'm technically not done simplifying the interior of that grouping symbol there, because that exponent can be factored. There's no extra cleanup that you can do on the interior of this big grouping symbol. So I hop outside and I look at the exponent. Now, before I go running that exponent, I'm going to ask myself, is there anything I could do to simplify that exponent? Technically, there is. I could write that exponent as 1 over x plus 2. So I'm going to go ahead and do that. And now I'm going to finally use one last law of exponents, which is that exponents raised to exponents end up multiplying. Once you get here, you see this is actually not bad, because we do know that we could divide x plus 2 out of both numerator and denominator of that exponent. And you're left with a final statement here that this is just 2 raised to the x plus 3. There's actually another way you could write this, but I think most people would be okay with that statement right there. In our final example, we're just going to do a little bit of factoring here. Turns out that all of these terms have an x to the negative 2 in common. Even though you do not see an x to the negative 2 right there, you can still factor, because all factoring is doing is dividing. So when I say factor out an x to the negative 2, that means divide each of those terms, the 6, the 23x to the negative 1, and the 7x to the negative 2, divide each of those by x to the negative second power. And when you look at that, at least the third term there, the 7x to the negative 2 over x to the negative 2, is very quick and simple. That is just a positive 7. And you can distribute the x to the negative 2 back in, and you'll see you have a positive 7 times x to the negative 2. It does work out. The other two are going to take a little bit of work. So I'm going to look at this 6 over x to the negative 2. Remember, that's a negative exponent on x to the negative 2 there. So I'll write that as a 6 times x to the positive 2. All I did was rip a negative off the exponent and take the reciprocal. So that is 6x squared. I could do a similar action on this. I will just exchange positions. That's a 23. Instead of an x to the negative first, I'll write that as x to the first downstairs. Instead of an x to the negative second downstairs, I'll write it as x to the positive second upstairs. And now you do a little canceling right there, and that's 23x. So this middle term is a positive 23x. And I did say simplify, so there's a little extra work you can do here. You can actually factor that. So that is actually completely simplified. You might have an instructor that would like you to write things without negative exponents. So that would be 1 over x squared. They are all equivalent. All right, so thank you for watching this video on working with negative exponents. As always, this content should be prerequisite to the course in which you are currently enrolled. If you found this material unfamiliar, or if it was confusing to you, then I recommend you click on the provided relevant prereq links listed below for further help. However, if you are continually doing this, you might want to consider speaking with your instructor about other course options. On that note, I sincerely hope these videos help you to achieve success in your transfer level math and science courses. Cue the music.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at ease. Listen close, don't talk too much, that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry. Don't whine, just